This is a short video lecture series about waste management. Nuclear waste is definitely something that needs to be dealt with here in the United States. The nuclear industry developed in the 1940s, and the first nuclear power plant was built in 1957 in Pennsylvania, about 25 miles from Pittsburgh. So the first nuclear power plant was built in Pennsylvania in 1957. In 1946, the Atomic Energy Act was passed, and that gives EPA the authority to establish the environmental standards and to issue recommendations based on radiation protection to federal and state levels. So the other agencies involved with overseeing and regulating the nuclear industry here in the United States includes the Nuclear Regulatory Commission, the U.S. Department of Energy, and the U.S. Department of Transportation. The Nuclear Regulatory Commission is heavily involved with siting new facilities, overseeing the construction of new nuclear facilities, licensing those facilities, and making sure that the operations are abiding by the state and federal laws for nuclear facilities. In terms of nuclear waste, it's the U.S. Department of Energy that oversees management of the disposal of spent nuclear fuel from nuclear power plants, as well as from weapons production and from nuclear research facilities. And then the U.S. DOT oversees the transport of commercially radioactive materials. So nuclear power is a critical part of our nation's energy mix and has reliably provided about 20% of our electrical generation here in the United States over the past 2 decades. It remains the United States' single largest contributor of non-greenhouse gas emitting electric power generation. When nuclear fuel goes through its reaction process, it doesn't emit any greenhouse gases like carbon dioxide or carbon monoxide. The reason it doesn't emit any carbon dioxide or greenhouse gases is because when the spent nuclear fuel goes through its processes, it doesn't go through a reaction that would spin off these gases. The only thing that comes from a nuclear power plant that's emitted into the atmosphere is water vapor. And that's because the heat from the nuclear reaction converts water to steam, and that steam is used to spin a turbine, and then there's water vapor coming off as a result of that. Now, that being said, one of the issues that we have to deal with in relation to nuclear reactors is the spent nuclear fuel. And the spent nuclear fuel is broken into different types of categories: low-level waste, intermediate-level waste, and high-level waste. And we'll talk about each of those. This map is of the United States, and it depicts the various locations of 104 operating nuclear reactors in the United States, as well as where reactors have been shut down. And some of these reactors still have spent nuclear fuel on site. So there's quite a few reactors that have been shut down in Illinois, as well as in New England area, and just a few over here in California. There's quite a few operating nuclear reactors in Illinois. In fact, Illinois has the most nuclear reactors. And then we have Pennsylvania with 9 nuclear reactors. And you can see the distribution of nuclear reactors throughout the United States. The diamond shape symbol depicts commercial spent nuclear fuel pool storage areas away from reactors. The dot with the X is considered to be a commercial dry storage site. There's 16 of these sites across the United States. And then we also have the blue triangles. These are 36 operating reactors, and then there's 11 which have been shut down, and these are research reactors. Finally, we have the yellow triangles, which are Department of Energy owned spent nuclear fuel and high-level waste storage facilities. And then there are the green triangles that indicate commercial high-level waste storage facilities. There's only one of these, and that's located up here in New York. And then the white triangles indicate surplus plutonium sites. So, as far as the waste quantities projected through the year 2046, it's expected that we have about 105,000 metric tons of commercial spent nuclear fuel that we need to deal with. In terms of the Department of Energy, they're expecting about 2,500 metric tons of high-level waste. Overall, we have 39 states and we have 131 different nuclear sites in those 39 states. So commercial nuclear power production in the U.S. has resulted in over 70,000 metric tons of spent nuclear fuel, and the fuel that is used and removed from nuclear reactors. And the inventory is increasing about 2,200 metric tons per year. If the spent nuclear fuel were assembled and stacked side by side, they would fill a football field over 17 meters deep. In addition, as mentioned on the map, there are some nuclear weapons production and other defense-related activities that creates about 13,000 metric tons of spent nuclear fuel and other high-level nuclear waste. So what's going on with this is that this high-level waste is extremely radioactive and needs to be isolated and shielded in order to protect human health and the environment. It's currently being stored at sites where it was generated. And after spending decades and billions of dollars to research potential sites for permanent disposal, including the one at Yucca Mountain in Nevada, by the way, it's not indicated on this map, but right in this area, about 50 miles away from Las Vegas, we have a nuclear waste repository site called Yucca Mountain that's all but been constructed, yet it hasn't been approved for actual use yet. Hence, spent nuclear fuel from commercial reactors is currently being stored on site at nuclear power plants around the country. While it is safe and secure in these locations, a long-term solution is still needed to ensure that the public and the environment continues to be protected. One approach that's being considered is that states in certain regions work together to develop regional nuclear waste storage facilities. In Pennsylvania, we have the 3 Mile Island facility located in Harrisburg, Pennsylvania. That facility was the one that was involved with the TMI incident back in 1979, where there was a partial core meltdown with nuclear reactor number 2, and that reactor still hasn't been brought back online. This facility is getting older in age, and recently it was sold to a company named Exelon, and Exelon is looking at decommissioning this reactor. And Pennsylvania is actually being considered as one of the states that provides the regional waste repository for the northeastern portion of the United States to store spent nuclear fuel. One location that could be considered is TMI. After they shut down the reactor, they could potentially use this facility as a nuclear waste storage facility. This map is depicting the amount of spent nuclear fuel in the various states across the nation. The darker the color that's shaded for the state means the greater the amount of spent fuel is being stored in that state. So Illinois and Pennsylvania already store greater than 5,000 metric tons of spent nuclear fuel. Illinois actually leads the nation in storage volume of spent nuclear fuel, followed by Pennsylvania and then South Carolina. And by the way, all the dots depict spent nuclear fuel storage sites as of 2014. So, a little bit more details regarding Yucca Mountain. In 1982, the Nuclear Waste Policy Act was passed, and this established procedures to evaluate and select a site for deep geological repository and storage of spent nuclear radioactive waste. It assigned the Department of Energy the responsibility to site, build, and operate a deep geological repository for high-level radioactive waste and spent nuclear fuel. 2 other laws were passed. One was the amendments to the Nuclear Waste Policy Act in 1987, and this directed DOE to specifically focus on Yucca Mountain as the site of consideration as a nuclear waste repository. Another law was passed in 1992 called the Energy Policy Act, and it was amended in 2005. And again, these laws focused on Yucca Mountain as the nuclear waste repository. However, as a way of background, the selection of Yucca Mountain as the nation's only site for disposal of spent fuel and high-level waste was actually a political decision, and that decision was not based on the site's scientific merit. Examples of key unresolved technical issues at Yucca Mountain included an active geological environment with earthquakes, oxidizing and corrosive subsurface environment, high seismic activity, relatively young volcanic activity, and rapid water flow and movement through the mountain. So it's no surprise that after extensive studying, it became increasingly apparent that Yucca Mountain failed to possess key waste isolation characteristics that would be required for long-term waste disposal of spent nuclear fuel and high-level radioactive waste. Nonetheless, in 2008, U.S. Department of Energy did submit a license application to the Nuclear Regulatory Commission to build Yucca Mountain. The state of Nevada responded to this request by filing over 230 technical challenges. Now, please understand, much of Yucca Mountain has already been built. It's been studied, and as the picture depicts in the top right corner, a tunnel actually extends into the mountain. So, Nevada's not happy about this being in their state. In 2009, the Secretary of Energy said that the repository of Yucca Mountain was not a workable option. And in 2010, the Department of Energy terminated its efforts to license the repository at Yucca Mountain. So it stopped in 2010, basically. Now, the U.S. Department of Energy announced that it was withdrawing its license application submitted to the Nuclear Regulatory Commission. But what happened next was that the Washington, D.C. Court of Appeals directed the Nuclear Regulatory Commission to continue with the licensing process, despite the fact that the Department of Energy did not want to pursue a license. Well, after terminating its pursuit of licensing Yucca Mountain, DOE proposed in January 2013 that a new waste management organization should be created, and using a phased, adaptive, content-based approach should site, license, and construct and operate a pilot interim storage facility for spent fuel by 2021, and then find a permanent disposal facility by 2048. So this is many years from now. So basically, U.S. Department of Energy is saying that Yucca Mountain will not work and we need to find something else. So at this point in time, Yucca Mountain site has been abandoned and nothing exists but a boarded up exploratory tunnel that was constructed. More than $15 billion has been spent studying this site and preparing it for the licensing procedure, and as well as dealing with some of the legal charges against the site from Nevada. So there is no waste in the tunnels, there's no receiving and handling facilities, and the waste containers and transportation casks have yet to be developed. Moreover, there is no railroad to this site. So the cost to build a railroad through Nevada could exceed $3 billion. Today, the only thing that actually exists at Yucca Mountain is a 5-mile exploratory tunnel. So this map depicts the world's nuclear reactors as of 2009, so it's a little bit outdated, but it gives you some perspective here. The red dots indicate operational nuclear reactors, and it tells you the number within each country. So there's 104 nuclear reactors in the United States, 18 in Canada, 17 in India, 31 in Russia, 59 in France, 17 in Germany, 10 in Sweden, and overall around the world there's 436 nuclear reactors. The gray dot indicates combined operational proposed planned projects, and it looks like we're going towards 898 total is what's projected. Now, in terms of the number of nuclear electricity generation in kilowatt hours, the country that is generating the most is the United States, followed by France. So we are considered to be the highest net producer of nuclear power in the world. China is actually pursuing nuclear power much more enthusiastically and on a bigger scale than anyone else in the world. It currently has 11 reactors and is pursuing the construction of 140 additional reactors. South Africa is also planning a major expansion in nuclear, as well as France, Japan, and of course the United States is keeping on board with it. As far as the nuclear power industry, the main thing to recall is that yes, it doesn't create greenhouse gas emissions, but yet it does create an issue pertaining to waste disposal, not only here in the U.S., but worldwide, because it takes 10,000 to 50,000 years for the waste to break down.